Hello, good morning, everybody. Welcome to Friday's edition of the Breakfast Club. And it's our last panel in our Oceans Week series, but not our last Oceans panel. On Monday, we talked about coral reefs. On Wednesday, we got into some of the incredible technology driving ocean exploration. And today we're talking about sharks. So if you have any shark lovers in your household, grab them, corral them. And it looks like our beautiful guests are all muted still. So unmute yourself so you can say hello. The really cool thing about this morning's talk is that we're live. So you can ask questions while our guests are speaking, and we will get to them, as many of them as we can. And so to introduce our guests to my left, we have Jada Elcock.
Hello.
An incoming grad student at the University of Washington who focuses on elasma branch ecology and conservation, and who's known for her lightning fast shark science on Twitter, TikTok, and more. Hello.
Hello.
And then next we have Dr. David Schiffman, a marine conservation biologist and researcher at Arizona State University, who studies the management of threatened shark species, but who might be best known as the Twitter legend, Why Sharks Matter. And hi, thanks so much for being here.
I'm happy to be here. Thanks for having me.
And last, unfortunately, our third original speaker, Vicky Vasquez, wasn't able to be here this morning. I think she's having some technical difficulties. So bravely stepping up to the plate is Dr. Luiz Rocha, the Academy's ichthyology curator, and a core member of our Hope for Reefs team. And he's done hundreds, thousands of dives. And so those have provided plenty of shark encounters. And so he has stepped up to talk about sharks, right?
Exactly. Yeah. I actually have to keep count of those because it's part of the insurance deals and everything. But I've done about 6,000 dives. So getting up there, and I'm always glad to see sharks and always glad to document them. So I have a lot of photos to share.
Awesome. And of course, I hope everybody, has noticed the amazing shark gear that our panelists have on today. So round of applause for that. Oh, yes. Lovely. Okay, we're going to get into it. Each presenter is going to give a short talk and then ask your questions while they're talking. We'll bring them all back at the end for even more questions. So up first is Jada. Wave goodbye, David and Luiz for now. And Jada, I'm going to get your slides. And
there's a background noise here right now.
Oh, I can still hear you.
Okay, awesome.
Everyone still hear you? Awesome. Okay, take it away, and we'll see you in a little bit.
Fantastic. I'm going to take this giant shark head off because it's kind of a lot. So some people might know me by my animal fact videos. Some people might know me for my love of sharks. Either way, today I'm going to kind of talk a little bit about both. A little bit about my science communication and why I think sharks are so amazing. So first we'll go over TikTok. If you don't know what TikTok is, it's kind of like Vine, but not quite as fun, but still entertaining. It's kind of full of a lot of like high schoolers and college kids doing weird dances, or honestly like dangerous pranks or like bad puns. Some of it's entertaining, some of it's kind of ridiculous. But overall, it's kind of it's a pretty fun app. But I think it's pretty underutilized for science communication because you can reach a younger audience that will soon be going into the next stage of their life and choosing their careers. So I feel like it's really important to kind of get to those people. And I'm sure that they're on Twitter, but if TikTok is what people are scrolling through for hours on end, you kind of want to utilize that platform. So I decided to start making TikToks, and I wanted to do it because I see so many people have like their specific thing that they do. I see artists displaying their art, drawing different states as people, or drawing different companies as people and things like that. And I decided I wanted to have my own little my little niche thing on TikTok. So I decided to start doing these animal fact videos. The main goal of it is just to kind of like educate the public on animals that they might not necessarily know about or care about. Obviously also to make people laugh, because it's always fun to laugh and it's more engaging that way. I just want to get people to care about these animals, because if they don't care, how are we supposed to expect them to make efforts towards conservation? So I think education leads to conservation by getting people interested and getting them to care about these animals. So that's kind of why I started making these TikToks. My process, people all the time ask me, like, how long does it take me? Probably between 45 and 60 minutes. So not really that much time. I have a list of suggestions that's probably 70 or more animals long from people on TikTok and Twitter messaging me, telling me I should do this animal, or this is their favorite animal. They'd really like to see something about this. So I'll pick an animal from my suggestions list, which is very difficult again, because it's so long. Like, how do you pick an animal? And I collect facts online, probably from like NOAA or Nat Geo or Discovery, any of those like sources that I try to make sure that I have like good sources, so I'm not spreading misinformation. And then I film it and I add captions. Usually my little jokes in there are ad libs. Sometimes when I'm writing the facts down, I think of one and I'm like, if I forget this, I'm going to be very upset. So I'll write it down. But yeah, just kind of adding those jokes in to get those laughs. I've done 136 videos total so far. And I've done, I want to say every group. I've done invertebrates, I've done fish, mammals, birds, reptiles, amphibians. I've done such small things like rotifers, and then I've done such huge things like the blue whale. So I wanted to get that variety in there, so it's not just ocean animals, because there are a lot of land animals that we think are super weird and need more attention as well. So I think any animal is awesome. I'll take any suggestions, and I will do my best to get to those suggestions so that everybody gets a chance to see their favorite animal represented. And they're just a lot of fun to make. So, I mean, it's awesome to be able to get that information out to other people, but it's fun on my part just because I learn a lot as well, because I don't always know a ton about all of these animals either. Like, I'm not really a bird person, but I learn a ton about birds just by making these videos. So here's an example of one of my videos, the coelacanth. I got a lot of comments saying that people finally know how to pronounce the word coelacanth, because it's a very weird word. But here's my coelacanth video. If it will work.
Hey there, friends, I'm back. More facts to talk about the Goblin Shark.
That's not the correct video. Wait. Technical difficulties. My bad.
Hey there, friends, I'm back. More facts to talk about the coelacanth. They can get to be 6.5 feet long, weigh 200 pounds, and live an estimated 60 years or more. There are two different species. One lives off the coast of eastern Africa, and the other lives in the waters of Indonesia. And they can live up to 2,300 feet deep. Their lineage has been around for about 360 million years, so they still retain some ancient traits. They've got big, thick scales, which you usually only see in extinct fish. Instead of a vertebral column, they've got a notochord, a hollow pressurized tube filled with oil. Even humans start out with a notochord, but as development progresses, we replace it with a real backbone. But these guys like to stick to the old model. If it ain't broke, don't fix it, right? Something else interesting is these guys have vestigial lungs. That suggests that a long time ago, ancient coelacanths lived in shallow waters and breathed air. You may also notice that they don't just have fin rays, they have lobes. Hence the group name lobe fin fishes. Try saying that 5 times fast. Fins like this are believed to be the origin of limbs. The idea is that lobe-fin fishes like coelacanths evolved into tetrapods, which makes total sense because if you've ever seen a coelacanth swim, it looks like they're walking. Seriously, look it up. It's awesome. The crazy thing is we thought these guys went extinct with the dinosaurs 65 million years ago, but then a live one was found in 1938 and we realized that they weren't dead. Oh, it's a real Avatar: The Last Airbender situation.
Also, if you know me, you know that Avatar: The Last Airbender is one of my favorite shows, so I had to put that in there. Yeah, I think the coelacanth is a super awesome animal, so I had to feature it because it's like an evolutionary kind of like in-between stage. People think of it that way, and the fact that we thought it was extinct for 65 million years and we realized that it wasn't, like, that's kind of really awesome. So I had to feature it. It's such an awesome fish. And then I had to pick a shark, of course, and I had to pick one of the weirdest sharks because why not? So here's one about the goblin shark. Up, sir.
Hey there, friends, I'm back. More facts to talk about the Goblin Shark. They averaged about 5 feet long, but the largest one ever caught was almost 13 feet long. They live throughout the world in tropical and temperate waters, but live sightings of these animals are incredibly rare because they're a deep sea species. They tend to stay between 200 and 900 feet deep, but they can go deeper. And like most deep sea animals, we assume that they come to the surface at night to feed. I would advise against swimming in the ocean at night. What do they eat, you wonder? We're not totally sure because they're really hard to get a hold of, so it's really hard to look at their stomach content. But they've definitely found fish, crabs, octopus, and squid in some of their stomachs. Now let's talk about this face. You ain't got no alibi because he ugly. First of all, they've got this weird skinny snout covered in pores. Those pores make up the ampullae of Lorenzini. That's the electroreceptor that sharks use to detect electric fields of prey. It's the ultimate snack radar. When they find a snack, they bite. And this bite is believed to be the fastest bite of all sharks. If you've ever seen a video of a goblin shark feeding, you can see that their body doesn't really move when their jaws do. That's because they can move their jaws independently. How? Their jaws are attached to ligaments, so it's stretchy like a slingshot. Also, they can open their jaws to like 111 degrees. If you did that, your chin would rest on your chest and you'd still look straight forward. Sure sounds like a goblin to me.
Yeah, so that's the kind of style I like to do. A lot of zooming in, which I think kind of adds to the comedy, and really fast. A lot of people have commented in the past saying, why do I put my videos at double speed? And I don't. I just talk really fast sometimes. Like when I get really excited, I just talk really fast. So that kind of just translates into these videos, and then it's great because then you can fit more facts into just one video, because with TikTok, the longest time frame you're allowed to use is 60 seconds. And you typically can't fit a lot into 60 seconds unless you talk at the speed of light. So that's what I try to do. And I also try to keep them family friendly because you want to reach people who might have children, because, you know, if those are going to be the future of science, like you want to make sure that they're getting engaged as well. So it's not just for adults, but I kind of try to make it for every age group, whether you're 2 or 45 or 87, whatever. I hope that this is something that everyone can enjoy. And then a little bit about why I like sharks. I think that they are super cool. They're crazy diverse. I mean, you have an animal that grows max to about 8 inches long, and then another one that grows to about 40 feet long. So it's such a huge range of different sizes that you can have. And then you have filter feeders versus highly predatory animals. You have this crazy weird head shape on the hammerhead shark and a more streamlined head shape on the great white or the mako shark. So just seeing all of that incredible diversity within sharks, I think, is really awesome. They're also misunderstood, which I know is super cliche to say, but it's definitely true. The way that they're portrayed in the media, we just kind of see them as like villains. And I think that that's a dangerous way to look at them, because they're not villains. They're super important parts of the ecosystem. So if we keep going at the rate we're doing with overexploitation, it's gonna have some really bad effects. So I just think that we should be able to get past our fear of sharks and not let that get in the way of the respect that we should be having for them. Also, the amount of strength and power they have and how amazing of predators they are, I think is just so, I think it's something to admire. Like you look at the great white shark and you see how big it is. It's got so much power. It has so much strength. Like its muscle mass is ridiculous, and it's just an incredible predator. And I think that that's something to be respected and admired, because that's just, it's awesome. And also shout out to Inka Cresswell. These are her photos. She's an amazing photographer and filmmaker. So if you don't follow her on Twitter, you totally should. And I believe that is my last slide.
Thank you, Jada. Some people said that they'd never seen your TikTok before, but it was really good and made them laugh out loud. Plus, they learned a ton, which is kind of, you know, the point of you doing this. So thank you so much.
Yeah, of course.
Quick question for you.
Sure.
It's a softball one, but if what's the cutest shark in your opinion? And have you done a TikTok about it?
I love thresher sharks because their faces they look surprised all the time. But I really like bonnet heads as well. I've not done one on bonnet heads yet, but I really want to. But they're so cute. Like they're little, they got like a little shovel head and they're so little and cute. Oh, I love them so much.
Okay, well, we'll look out for that in the future.
Yes.
Okay, thank you so much. Going to remove your slides, and we are going to have Dr. David Schiffman join us.
Hello.
See you later, Jada. Hi, how are you?
Doing great. How are you?
Great. Do you want to add your slides? I can't.
Yes, sharing screen
Okay.
here.
Great. Are you going to leave your hat on for this talk?
I think I am. Jada may have a better hat than me, but mine's more comfortable.
Okay. Great. I see your slides. So I'll see you after your talk.
Wonderful. All right. Well, thanks, everybody. I'm excited to talk to you today about how people can protect sharks, and as well as some things that people are doing that are not particularly helpful to protect sharks. And before I get started here, I want to note I am, as was mentioned in my introduction, I love the social medias. You can find me on Twitter, Facebook, and Instagram at Why Sharks Matter, and I encourage you to ask me questions later if I don't get to your questions today, or if you're not watching this live, or if you want to tweet anything from this talk, you're welcome to. I just ask that you please tag me at Why Sharks Matter. And if you want to learn more about any of the issues that I present today, please visit my website, davidschiffmancv.com, especially the publications and seminar notes tab. You can find copies of all my peer-reviewed publications, as well as links to articles and such that I discuss during this talk. So I'm not going to be talking directly about sharks today, though I do spend a lot of time working with sharks. I'm going to be talking about the human dimensions of shark conservation. What that means is the sort of work that I've been doing, especially lately when I can't get out on a boat because of the virus. I've been doing a lot of policy side work. I've been doing a lot of public understanding of sharks. I'm interested in what people know about sharks and where did they learn it, and how that influences their attitudes and policy preferences. So before I get into this rant, and I do have talks and I do have rants, this one's definitely a rant, I want to give some quick general definitions. I'm referred to an expert environmentalist as someone who has some professional training and experience with conservation advocacy. Such a person is usually, but not always, affiliated with an environmental nonprofit group that has resources and a track record of success. And such a person is also aware of basic background facts associated with a conservation issue and is aware of the process required for policy change. In contrast, a non-expert, I do not mean that as an insult, I do not mean that as a diss, I mean it as a technical definition. That's someone who cares about the ocean and wants to help but does not have these other characteristics. And that may well be some of you who are watching today. So Johnson et al. 2004 reminds us that sometimes scientists need to know our role and shut our mouth. So my role as a scientist, there are things that I won't do, and there are things that I think it's important for scientists to do. I would never, as a scientist, say to a non-expert activist, it's bad that you care about this. Why do you care about this when you should care about this other thing that I personally think is more important? That doesn't work. But what you can do, and what I think more scientists should do, is when people say that they care about something, you can say, oh, it's great that you care, but the facts that you're using, that you seem to be basing your argument on, are wrong. It's great that you care, but we know how to get policies to change, and it's not what you're doing. And in fact, we know that what you're doing doesn't work. And sometimes it's okay or even appropriate to say, it's great that you care about this overall cause, but within that cause, this other issue is much, much, much more important than the issue that you're focusing all your time and attention on. So put another way, the problem here is that the number of people who know enough about a problem to solve it effectively is much, much, much smaller than the number of people who care and want to help but don't know how to help. Traditionally, how this would be resolved is such people would join become members of or donors of or subscribe to a mailing list of a traditional environmental nonprofit group that employs experts and has expertise and institutional knowledge, and would be able to say, hey, we need your help. Will you sign this document? Will you write your elected officials in support of this issue that we're working on? And this model works very well. But the new wrinkle here is, thanks to social media, it makes it easier than ever before for anyone to spread information, including misinformation and disinformation. It makes it easier than ever before for anyone to create their own advocacy campaign. And what that means is there are lots of people who don't know what they're talking about, who have positioned themselves as leaders on these issues, and they spread wrong information that confuses people and makes the problem worse. When I do my professional development training sessions for scientists who wish to use social media, I refer to David's third law of the internet, which is social media. The great thing about social media is it gives everyone a voice, but the terrible thing about social media is it gives everyone a voice. So this is indeed a problem. This is just not something, it's not just something that annoys me. It's something that causes measurable harm. And that's because the environment is in trouble. And the environmental community, people trying to fix it, have limited resources that need to be applied to the most effective solutions. And there are a lot of people who care and want to help, but not a lot of people who have enough time and energy to, say, chain themselves to a tree for several weeks to prevent logging in old growth forests. Some people only have a few minutes a week to dedicate to a particular cause. And if they spend their time helping with nonsense, then they can't spend their time helping real groups solve problems in a real way. Or put another way, it's great that people want to help, and it's great that people are trying to help. But wanting to help and trying to help is not the same thing as helping, and good intentions do not excuse easily foreseen harm. I want to go through some examples of non-expert-led campaigns that are causing harm in the shark world. When I lived in Florida, where I got my PhD at the University of Miami, I saw maybe a dozen online petitions made by amateurs, by things like the petitionsite.com or change.org, asking Florida to ban shark finning. These got tens of thousands of total signatures, a lot of people spending their few minutes a week on this. But the thing is, we did ban shark finning in Florida in 1994, which means that this petition cannot possibly do any good at all. All it's going to do is waste people's time and energy and spread confusion. A quick note here that the term shark finning does not mean what a lot of people think it means. It refers exclusively to catching a shark, cutting the fins off that shark, and dumping the carcass overboard where it will slowly bleed to death or drown. If the carcass of a shark makes it to land, that shark has not been finned, even if the fins are later removed and sold. That's just what the words mean. Another issue in Florida with non-experts spreading misinformation, there was, when I was there, Florida's shark fishery, which has existed in some form since World War II, and is absolutely not a new thing. They changed what date they were opening for the year in 2016. And some non-experts wrongly believed that this meant that Florida was creating a shark fishery for the first time. And they spread a lot of inflammatory rhetoric that resulted in hundreds of angry phone calls and threats and violent harassment towards marine biologists and government officials, based entirely on a misunderstanding that could have been cleared up if someone asked an expert. And there was one group that was a particularly shady scuba diving operation that exploited this and said that all the sharks in Florida are going to be killed in 3 days because of this decision by the government. So you should come give me money to go swim with the sharks while you can. Another issue, this is a particularly strange one. If you've ever been to Florida or the Outer Banks, and it's probably a few other places too, but this is where I've seen it, you see these dead sharks in a jar for sale at tourist shops. I don't particularly understand why anyone would want this, but I actually have one. My great aunt got me one when I was 5. She said, "Hey, you like sharks? Here's a dead baby shark in a jar you can put on your desk." I don't get it, but this is presented by non-expert activists as a major conservation threat, phrased with things like, shark populations will never recover if we're killing the babies too. And I want to be clear that while this is creepy and weird, this is absolutely not what's happening here. Shark babies are not being killed to be put in jars. These are babies that were inside mothers that were caught as part of a well-managed, sustainable fishery. Not a single shark ever has been killed to be put in a baby, or to have its babies put in a jar, which means banning this would not save sharks. There's also a strange phenomenon recently of consumer boycotts of well-known, often beloved brands that have a very, 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 very tenuous connection to shark conservation issues. You may be wondering, for example, what Starbucks has to do with shark conservation and why they've been singled out by this small extremist nonprofit group for causing harm. Well, here's what I mean when I say very, very, very tenuous. When Starbucks sells their coffee in Southeast Asia, they have to go through a food importer, exporter, distributor company like everyone does. And the one they used is owned by a holding company, which is owned by another holding company. That other holding company owns thousands of food service businesses, including a restaurant that serves shark fin soup. So I don't particularly think it's fair to blame Starbucks for this, though these consumer boycotts get a ton of media attention and go viral on social media all the time, even though they can't help. I do want to note really quickly, though, that a consumer boycott of in 2013 of an Atlantic City hotel that was serving shark fin soup was responsible for these, I swear to God, real tweets. Sharks are last on my list, other than perhaps the losers and haters of the world. There is a small but vocal minority of these non-expert activists who believe that the only threat that sharks face is from scientists studying them. And if we would only leave sharks alone, they would be fine. And that is just such a deeply unserious approach that I don't even really know where to start. But that image that you see in the middle bottom there is a screenshot of one of my columns for Scuba Diving Magazine. I write a monthly column for Scuba Diving Magazine called Science Stop. And I addressed this last summer if you'd like to learn more about this. But this is just nonsense. There's also a growing problem of non-experts who believe that by hugging and kissing and grabbing and riding sharks, they are somehow helping. And let me be clear, this is not helping. This is not conservation. This is not science. This is not education. This is not outreach. This is wildlife harassment. It's bad for sharks. It has resulted in humans being killed. You should not do this. You should not listen to people who do this. You should not idolize people who do this. And there's also a growing problem with anti-intellectualism. Don't worry if you can't read these quotes. I'll read them. I know it's small text. I'll read them in a minute. But this is a problem of not just being unaware of expertise, but being actively hostile towards experts. And this photograph is one that I took when attending a shark research conference. Those people are protesting the shark research conference, not because, as you might suspect, sharks are scary and they think we should kill sharks instead of study them. But no, they think sharks are cute, adorable animals that scientists shouldn't study at all. We should leave them alone. Trying to talk with some of these people was one of the most surreal experiences of my life. And that was before they did what you see on the right there, which is they shared our photos of conference attendees on their social media and said, this person is a shark murdering Nazi war criminal and you should harass and threaten him if you see him around town. This is not great. You should not do this. You should not listen to people who do this. But some of the quotes here that are some of my favorite are comments I've collected over the years of these non-expert activists ranting about science that they haven't bothered to understand. Sharks are wrestled and stabbed by scientists for a few minutes of glory. I don't think sharks should be studied at all. Just leave them alone completely, utterly. Scientists are torturing poor animals for research and other sick reasons. This is just, again, a deeply unserious approach to ocean conservation. A quick note here that whenever I criticize some of these activities, people say, oh, it's okay, we're raising awareness. And raising awareness is important. Raising awareness of a problem and how to solve that problem is a critical part of environmental advocacy. However, raising awareness of wrong information and solutions that don't work doesn't help anything or anyone. And if your stated goal was changing a law and that law doesn't change, you can't say, well, we succeeded because we raised awareness. Also, people respond to these criticisms with, well, at least we're doing something, which is a very strange argument because doing something bad is not better than doing nothing. Doing something that wastes the limited resources of the environmental movement without helping is not better than doing nothing. Doing something that makes a problem worse is not better than doing nothing. So at least we're doing something is a very strange argument. So what can we do about this? There are lots of people who care about the ocean and want to help. That's great. Can we get these people to support effective, expert-led, evidence-based, data-driven conservation campaigns instead of what they're doing now, which is creating their own ineffective, non-expert campaigns, diluting our resources, what I term reinventing the wheel poorly? And the answer is kind of maybe under some circumstances we can do this. You can't reach everyone. There are many non-experts who are well-intentioned and really just want to help and just don't have the background knowledge that experts have. And if you reach out to them and speak to them, some of them can absolutely become enthusiastic, passionate, valuable allies. But there are, as mentioned a few times in this talk, people who are actively hostile towards experts and expertise. And I can tell you from a decade of experience with this that engagement with these individuals is unlikely to result in them changing their mind or stopping or apologizing. So what can you do? How can you help sharks and the ocean? And how can you avoid causing harm to sharks in the ocean? Well, conservation science is a thing. Threats to sharks are well documented and solutions to these problems are well studied. You don't have to guess and you don't need to listen to people who guess. You don't have to reinvent the wheel poorly. You can listen to experts and not listen to people who are not experts, who do angry rants that could be rephrased as the sky is falling and the experts don't have a clue and I alone can fix it. Give me all your money. Don't listen to those people. Don't share their articles on social media, and instead listen to experts, because you absolutely can help and we need your help. We just don't want you to make the problem worse for us. I want to thank you very much for listening to my rant today. Again, I'm at Why Sharks Matter on Facebook, Instagram, and Twitter. I'm always happy to answer questions that people have, especially if we don't get to your questions during live today or if you're watching later. My website is davidschiffmancv.com again, and my email is whysharksmatter@gmail.com. Thanks for listening.
Hey, David, thank you. So how, with people who want to avoid getting, involved in campaigns that are, more hurtful than helpful, where do they start? Where do you start if you want to get involved?
So there are a variety of reputable, well-loved, well-known conservation organizations that work on these issues, and see what they're doing. And you don't. If this is one person without an organization behind them, who is claiming that everything the scientists are saying is wrong, that should be a red flag to you. If you needed open heart surgery and you approached someone and they said, oh, everything that's known about cardiac medicine is wrong, listen to me, even though I don't have any training or experience and will do surgery in my backyard, you probably wouldn't do that, I hope. This is the same thing. Technical problems require technical expertise. And someone who dismisses the very idea of expertise is someone who is unlikely to be particularly useful. Most of these people are pretty easy to identify as non-experts who are ranting about nonsense. Every once in a while, there are people that do a pretty good job of presenting themselves as reasonable, reputable experts when they are not. But for the most part, people are not actively trying to trick you. They just don't care that you think they're not experts, because there are plenty of people who won't check.
Yeah. Great. Thank you. I am going to take off your slides and bring Dr. Luiz Rocha to the screen, and see you later, David.
Bye.
Hi, Luiz.
Thank you.
So just one thing you said earlier, you said something about insurance and sharks and the number of dives. What does that mean?
It's just a work thing. So for work, we have to have work insurance and liability insurance and things like that. And for diving, it's a risk activity.
Okay.
So to have the proper insurance for that, we have to keep a record of everything we do on the water. So I have to actually, it's part of my job is counting and reporting how many dives I do. That's why I know exactly how many dives I did.
Okay. Thanks for clearing that up.
Yeah.
I was wondering. I think people are wondering.
Right.
Okay. Well, I'm going to add this beautiful photo of a shark, and we're looking forward to hearing your shark stories.
Thank you. Thanks for having me. Thanks Jada and David for such nice talks. They both served as inspiration and a good introduction to what I will be talking about. I'll start by giving a little disclaimer here. As David said, it's very important to listen to expert advice, and both David and Jada are much more experts in sharks than I am. I am an ichthyologist, so I'm a fish biologist, so I know quite a bit about sharks, but they're not my specialty. My specialty is coral reef fish, which also happens to be my handle in both Twitter and Instagram. Where I share a lot of, including sharks, but a lot of pictures of reef fish, sharks, and other cute marine organisms, invertebrates, you name it. If it lives underwater, I photograph it and I share it. And social media is becoming a great tool for science communication. As David said, it's both good and bad at the same time. But I like seeing how good it has been at communicating a lot of the science that we do. So I'm not going to talk about my work so much, but more, well, in the end, I have the one paper I published about sharks that I will talk about. But at the beginning, I'm mostly going to focus on other shark projects that I was a part of, and I helped collect data for but I didn't publish it. So I'm going to talk more about the field related side of it than about the actual science in it. And I'll touch on the science as much as I can, as much as I feel I'm an expert that can give you reliable information about it. So David has already mentioned shark tagging, and shark tagging is something that I helped a lot of my colleagues do. This is our team in the Northwest Hawaiian Islands. I was there doing a different project. I was diving and working on my coral reef fish, which are my specialty. But between dives, we would go out and try to fish those sharks. In this case, it's a big Galapagos shark, to tag them. And as David said, a lot of people are against this type of work because it kind of seems like it harms the shark. But the impact of it is so small, and the amount of information we gain from it is so big that it's something that we can only gain from. So in the case of shark tagging in specific, we tagged about 15, 20 sharks in the Northwestern Hawaiian Islands. This is in the Northwestern Hawaiian Islands. This was before it became a big park. So the data that we collected during those shark tagging ventures there was used to better design the marine park there, the marine protected area. And that's the kind of information we get from shark tagging. So there's several ways you can tag the sharks. The ways we were doing there, because the shark was exposed and vulnerable like that, we were already pulling it almost entirely out of the water. We try to put as many tags as possible in the shark. So we put 3 different types of tags: a radio tag, which I'll talk a little bit more about in a bit. Then we put just a collar tag that doesn't come off. So the radio tag we put internally, we would make a tiny little suture, a tiny little cut on the belly of the shark. Then we put the radio tag inside, and then we sew that back on. We put a collar tag that is a permanent tag that if the shark gets fished at some point, there's a number there that people that catch the shark can call us, and then they can give us the code that is in the tag, and then we know exactly where that fish and how long ago that shark was tagged. And then the third type of tag that we put is the satellite tag, a pop-up satellite tag. That's a tag that is attached to the dorsal fin, so the back fin of the shark. And it transmits information to the satellite, either when the shark goes up to the surface. You know that some sharks go up to the surface and they like swimming with their dorsal fins out of the water. When they do that, the information from the satellite tag gets uploaded to the satellite, and then we know everything that the shark did in the past few hours or so, as long as the satellite tag transmits information to the satellite. For example, we know how deep the shark was diving and what the temperature was, and so on. And then in the end, so that satellite tag is attached to the shark with tiny little screws that are biodegradable. So with time, they dissolve, and they are manufactured in a way that they dissolve exactly at the same time as when the battery on the tag runs out. So say that the battery lasts for about 6 months in one of those satellite tags. So the screws that attach the tag to the shark also dissolve in about 6 months. And when they dissolve, that tag pops up to the surface. So another name for the tags, it's a satellite tag or it's a pop-up tag. So when that tag pops up to the surface, it transmits its position to the satellite. And then we as scientists, we can go there and then get the tag. And then when we get the tag, we download all of that information that tells us everything the shark did during the whole 6 months that they had the tag attached to it. So it's really, really good information to have when you want to design a marine reserve that is effective, which is something I'm very passionate about. There's a lot of marine reserves that are designed in a way that doesn't really help marine species, and it's the same problem that David was talking about. If you design them in a way that they don't help the species that they're supposed to help, they end up in a problem because instead of, they give this false sense of protection, and at the same time they take away from protecting the actual species. So they're really bad in many ways. So that one was just, the picture was just about after the shark was captured. This one, you see Carl Maya is the one with the hands underwater there. He was putting the permanent tag. That's the permanent tag, the one that's always permanently attached to the shark. And then this one shows us putting the radio tag inside a tiger shark. That was the biggest one that we caught during that that shark tagging portion of the trip. That shark was about 5 meters long. It was a giant female tiger shark. We put all 3 types of tags in it, and that one, it took a bite out of the boat, a chunk. It was this big. It's an inflatable boat, but it has foam inside of it, so we weren't at danger of sinking, but the bite that it took was scary. So after that shark was tagged, we came straight back to the NOAA ship that we had, where we had our base, and then we took the boat out of the water and it had to be repaired immediately. So a little bit more about that radio tag. So the satellite tag, it comes up and then it transmits the information to the satellite. And the radio tag, it's a frequency that doesn't travel too much underwater. So it's inside the shark and it keeps pinging information. But it only works when it's close to receiver. So in this photo there, it shows a buddy of mine, Yanni, looking at the receiver. So we have a array of those receivers throughout the Northwest Hawaiian Islands and the main Hawaiian Islands that receive information from those tags. So every time a shark that has one of those radio tags inside of him, every time they swim by one of these receivers, the receiver is what receives the information, and then it records the presence of that shark at that particular receiver at that time. So then we go every 6 months, again, the battery on those receivers, they last about 6 months. Every 6 months or so, we have to go and replace those receivers. We take the old one and we put a new one on. And then we go back to the lab and then we download all the information from the receiver to figure out which sharks swim by that particular location. And we have an array of receivers that covers a really big portion of the island. So we know exactly where every shark was. And this was really important for protection of many shark species, because there were a lot of shark species that a lot of people thought that they would venture very far into the open ocean, while they don't. They're really site attached. They stay close to the reef. So that obviously has very important implications in marine reserves. How big do we want the marine reserve to be, and what kind of area you want it to cover. So you want it to be big enough to protect as many species, but not too big to not protect anything it doesn't need protecting. That one, it kind of confusing there, but the receiver is attached to that cable, and the cable runs all the way to the surface, and then there's a buoy in the surface. So that's how we can come back and look at that particular tag. So during that same day, this particular tag is relatively close to a place in Hawaii where they have those tourist diving. If they take the tourists to dive, to snorkel in this case, with the sharks, and it's a very interesting thing. It has its benefits, and it also has its drawbacks. The benefits are that the tourists that do it, in this case, they're all inside the cage. They get this up close and personal experience with the sharks, and they most definitely come back home having a new appreciation for sharks, and probably a new meaning of what being a shark is, and how marvelous these animals are, and that we need to protect them. The drawback is that because the whole operation of diving with sharks inside a cage or outside, it only works if you have sharks, and the way this is done is by attracting the sharks using food. So whenever this tourist boat goes out with the shark divers, or the shark snorkelers in this case, they put chum in the water, so they put dead fish in the water to attract the sharks, and the sharks come and they get their snack, and they get viewed by the tourists. In some cases, when it's done well, it works In other cases, as David said, when people start harassing the sharks and touching them and getting too close, and there's a bite or something like that, then it's bad for everybody. It's bad for the sharks. It's bad for the person. It's bad for everybody involved. So as you can see there, I'm the one taking the pictures, so I am outside of the cage. And that's another misconception people have about sharks, is that they are these like killing machines that eat everything underwater. And that couldn't be farther from the case. Yanni and I and our other buddy that day, we spent hours in the water. I was snorkeling with these sharks. There was food in the water, and they were getting even close to us. They only started getting close to us and kind of in a more curious than an aggressive way when the tourist boat left, and we were the only things left in the water. So obviously they stopped being interested in the food that was being given to them, and then they started getting interested in us. And in this case, there we're swimming with our fins toward the sharks because they were getting really, really close. This one got so close that it touched the dome port of my camera with its nose. It bumped into my camera, so that was the sign for us that it was about that time that we needed to get out of the water. They let you know. That's the good thing about sharks. Whenever there's something going on, something wrong that you're doing, they let you know. They start swimming a different way. They start getting more aggressive, and you're like, okay, that's it. It's time to get out of the water. So that for the most part, if you're an expert, if you know what you're doing, you get out of the water before it gets shady. So I want to talk a little bit about shark reproduction now, which will bring me to the paper that I said I published on sharks. These are Galapagos sharks. I photographed them in the dive that I just said that I did with Yanni in the Northwest. And this one was actually in the main Hawaiian Islands. And I want to draw your attention to that little circle there. I think it's not even showing very well, but it's a little circle close to the bottom fin of the shark. Let's see if I can show it in a better way. Where is my tab here? Oops. This circle there, I hope you can see it, but it shows the intromittent organ of the shark. It's called a clasper. It's a modification of the fin that allows the shark to internally fertilize the female, which is very different from most fish. So most fish, when they reproduce, they go out in the water, up in the water column, and they spawn. So that the female releases their eggs, the male releases the sperm, and then the fertilization is external. And then the eggs, in some species, they go to the bottom, they attach to the bottom. In other species, they go up to the plankton. But in most species of fish, there's this external fertilization with a lot of eggs and a lot of babies. That's one strategy of reproducing, right? You have a lot of tiny little babies, baby fish, very small, and you hope that as many of them survive. And because you don't know that many of them are going to survive, you reproduce in this case as much as you possibly can. So it's as many eggs as possible. So some fish like tuna, for example, every time they reproduce, it's thousands and thousands of babies they produce. Sharks are very different because they have internal fertilization. The females get pregnant. So that one is the male. The next one here, that's the female. Might be pregnant. I don't know. It might be just ate something. It was taken in that shark feeding dive. So it might be just that it ate a bunch of fish and it's looking a little rounder than usual. But females, they get pregnant. They have this gestation period that varies a lot between species. It can go from 3 months to, I don't know, 6-8 months or so. So it takes a long time for them to reproduce. And the babies grow internally in the female. So they develop internally, just like they do with us. The females get pregnant. The baby develops internally. And then when it's time to give birth, the female sharks, they give birth to small babies. Now, because the baby sharks, they're much bigger than the tiny, almost microscopic fish larvae from the other fish. They invest a lot in reproduction to make sure that the babies survive. That's a different strategy of reproduction altogether. But the consequence of that is that their capacity to recover from impact in the population is not very big because they can't reproduce very fast. But their babies have a much higher survivorship than the babies from a tuna, for example. If a tuna spawns, I don't know, 10,000 eggs at a time, maybe 100 of those are going to survive. When a shark gives birth to 5 or 10 pups, most of them survive because they're born very large already. So they eliminate a whole bunch of predators. They already have their teeth. They already come out feeding. So it's a different survival strategy. Now that brings advantages, as I said, and problems. The problem is that because their populations is smaller and they take such a long time, the gestation period is very, very long. They don't reproduce very often. They only mate once a year or so. And for some species, that can be a problem because because they're predator, they tend to live alone. They don't live in very big schools because there's not a lot of resources. If you imagine a whole bunch of sharks living together, if they all want to feed at the same time, there's going to be no food left for any of them. So shark populations and predator populations in general tend to be smaller than populations of fish that are lower in the food chain. So herbivore fishes in general have much bigger population than their predators. So because there's fewer sharks out there, sometimes it's hard to find a mate. And that's where my paper comes in. So that's a paper I published just a few months after I joined the Academy, almost 10 years ago now. I can't believe it's been almost 10 years. But one of the first projects I did when I joined the Academy back in 2011 was look at these sharks. So when I came in, there were these bamboo sharks that lived in this Tarnahat aquarium. And we had 3 of them. There were only females. And they had been in the tank for about 3 years. And they always laid eggs, but the eggs never turned into anything because there were no males. So you need a male to fertilize the egg and in order for it to become a baby, right? This particular species, it has a strategy to avoid extinction, basically, by cloning itself. So if it's a really, really tough time, there's no food around, there's something, I don't know, global going on, like the extinction of the dinosaurs, or maybe less dramatic than that, climate change or something like that, something that causes their population to go down by a lot, and the female can't find a mate. Sometimes when the female lays the egg, they produce little clones of themselves. So they clone themselves, and then the baby that comes out of the egg is a perfect copy, perfect genetic copy or a clone of that female. Several species of bamboo sharks do that. It's documented. And because these sharks were in the aquarium for such a long time, 3, 4, 5 years sometimes, we were expecting them to produce viable eggs. We always expected them to produce the eggs, and then the eggs would be wouldn't turn into shark babies. So to everybody's surprise, one day there was a shark baby that came out of that egg, and everybody was really, really puzzled about it. So we decided to get that baby, take a little sample of the fin of the baby. We didn't kill it. We just took a little sample of the fin, and do a DNA test. So do a paternity test, just like we do with humans, if you want to know who the father is, right? So if we compare the genetic material of, even though we don't have any candidate fathers in this case, because the females have been in the tank for such a long time, we can do a genetic test. So we first of all, we didn't know, because they usually do this at night, they lay their eggs at night. We didn't know which one of the females was the mother. So we had 3 females, we had this egg that turned into a baby, and we wanted to know which one of the females was the mother. So we also sampled all of the females. We did the same genetic test that we did in the baby, we did it with the females. And we also wanted to know if it really was a clone or whatever it was. When we did the genetic test, to our surprise, even though those females had been separated from males for about 4 years, the babies, it turned out, they were not clones. So we can't tell who the father is because we don't have the DNA of the father, but we could absolutely 100% tell that the DNA from the baby came from two different individuals, a male and a female. Now, this is when it really gets interesting. So one of the strategies of the species to keep going in those dire times, the times when it gets really bad for the sharks, one of the ways they evolutionarily adapted to overcome those conditions, well, one of them is the one I already talked about, which is cloning. The other one is sperm storage. So sperm storage, the females, they have a special kind of organ in their bodies close to their eggs, where when they mate with a male, they kind of capture and store the sperm there. And they store, the sperm remains viable for quite a long time. Before this paper we published, the longest documented case of storage was like 8 months. So they had a female in an aquarium for 8 months or so. That female gave birth a few months later, laid an egg, and where they did the same kind of test we did, and they found out it was a baby, the same thing. The baby had both a father and a mother. It wasn't just a clone. So it was documented for these species before, but this really expanded the time that a shark could store sperm for more than 3 times what was known before. We had no idea they could keep the sperm viable for this long, and it's super interesting, and it also has deep ramifications for the evolution of the species, because having a baby that is not a clone is much better for the population than having a baby that is a clone. So if you have a baby that's not a clone, it's adding to the genetic diversity of that population. So the more diversity you have in the population, and that works for human populations, by the way, too. The more diversity you have in the population, the more that population can absorb and fight and repel things that are thrown at it. So right now for COVID-19, for example, if we didn't have the human genetic population that, structure that we do, if we didn't have all of this beautiful diversity that we do, that we have, the effects of these viruses would be much bigger. Now, because we have people of all different races with all different genetic backgrounds, everybody fights the virus in a different way, and some people fight it better than others. If we had just one homogeneous population with a bunch of people that look the same, everybody would be subject to the same effects from the virus, and the impact in the population would be much bigger. So the more genetic structure, the more genetic diversity you have in a population, the better for the population it is in the long term. So the way the sharks developed to keep that going, even though the female shark can't find a mate potentially for years, is by storing the sperm of the shark. That's how important evolutionarily the genetic diversity is for species. So they store the sperm, and then they keep the genetic diversity of that species going for as long as they possibly can. All right, so with that, I will stop and I will open it up for questions. I hope there's a lot of questions, because I like Sharky Talks.
Hey, Luiz, thank you so much. Yeah, we've got a bunch of questions. I'm going to bring Jada and David back on the screen. Hello, everyone.
Howdy.
Yeah. Okay, ready for some questions?
Oh, yeah.
To the viewers out there, you can still ask. We still have time, so drop any questions you might have. Can you still hear me? I think my computer just disappeared for a second. Okay, great. So actually, a few people had questions about the cage diving that I think Luiz and David both brought up. They're just basically asking, like, how is it still available, that people are still doing it? Does frequently feeding wild sharks with chum have potential to alter the behavior of sharks around humans? And just generally, what are your feelings about it?
You go for it first, Shark, David, because you're the expert.
In general, wildlife tourism, as Luiz said, can be great. It can help make these animals more valuable to local communities, alive than dead. It can inspire a lifelong love of the animals when you get to experience them. That's a lot better than reading about them in a textbook. But there's a lot of operators that are not particularly responsible or safe, such as who I ranted about some of them during my talk. There's one person in particular who keeps repeating over and over again, sharks aren't, not only are sharks not dangerous, but they're adorable, cute, innocent puppy dogs that just need hugs and kisses. 2 of his customers have been killed by sharks. You would think that you would stop doing that. The good news is it is generally very easy to tell the difference between a responsible wildlife tourism operator and a macho cowboy idiot, which is how I term these other operators. The macho cowboy idiots don't hide it. They are trying to appeal to the extra thrill-seeking people that are willing to take unnecessary risks, which is dangerous for both sharks and humans, and not just the humans who pay at the time, but the next humans that those sharks encounter. One thing that I want to note here is, in general, feeding sharks a little bit doesn't do much as a big problem. It's just a little snack. But there are absolutely some groups that feed sharks a lot, so much that they come to associate humans with food. Due to the pandemic, there are sharks in this world that have been fed every day for 10 or 15 years that haven't been fed the last 2 or 3 months. And I sort of wonder what's going to happen to the first human that encounters those sharks. I have no idea. But I wouldn't want to be the first human to encounter those sharks.
That's an interesting question. I have a story about this. I did field work in French Polynesia a while ago, and I was looking for a reef fish species to sample for genetics, Lucanus casmira, a species of snapper, and we weren't finding anywhere in the island. And we started talking to the local divers about it, and they said, "Oh, they're in this point, in this point." They gave us GPS coordinates. So when we went to those points, we had no idea what the points were. We just got to the GPS point, we dropped the anchor, and before we jumped in, the boat was circled by sharks, and I immediately knew what the point was. It was a shark feeding place, right? But we decided to dive anyways, and as soon as we went down, lo and behold, the sharks started following us. At one point, I mean, we did find the fish; they were there. But at one point, I don't know, 15, 20 minutes into the dive. So usually a tank lasts for about an hour or so, depending on how deep you are. But 15, 20 minutes into the dive, we had to get out of the water because the sharks, we started harassing us because we didn't have food.
Wow. Okay. And I think there's a question at the very beginning that I think probably people wonder, but are maybe afraid to ask, but what makes a shark a shark? Just basic question. They said there's so many different species and varieties. So how do you explain that?
Jada, you want to take this one?
Sure. So first they have a cartilaginous skeleton. So it's entirely made out of cartilage. Like the jaws that you find are like calcified cartilage. So it's not technically bone, but it's a little bit harder. So they need to have their cartilage skeleton. I'm trying to think of other specifications because there are more animals that have cartilage skeletons than just sharks.
That's the big one for sure.
Yeah.
But there's technical definitions but in general, we're talking about a skeleton that's made. It's a fish that has a skeleton that's made out of cartilage, not bone.
Okay.
Great. Clears it up for everybody. This is a good question that just came in from Marcus, and they ask, what does the panel find to be the biggest challenge with SciComm surrounding sharks?
I would say the biggest challenge around SciComm with sharks is, I guess, just getting people to not be so fearful. And it's like some people just have like irrational fear. Like they know that like it's such a slim chance of being attacked by a shark if you were to go in the ocean, but they're still afraid of it. Like you're not going to cure an irrational fear. Like I'm irrationally afraid of spiders. I know that they're not going to do anything to me, but for some reason I just find them creepy. And like that's just kind of the way things are. But I think that we want to make sure that people are respecting them more than they fear them. And that can be kind of a tough balance to find for some people. So I don't know, I just like to give statistics like you're way more likely to get killed by a vending machine than a shark, which is really surprising for some people, but that's true. So things like that might make them laugh or kind of realize that sharks aren't nearly as dangerous as we think they are. But also, like we've been saying, like maybe don't harass them. Like that's not a great idea, but they're not inherently like vicious animals. It's just kind of the biggest issue is kind of trying to find that balance between fear and respect and making sure that it's more respect than fear.
Yeah, and a challenge that I face getting with it reaching largely a different audience, but some of the same challenges, is a lot of the conservation solutions, the expert-backed ones that I talk about, are very technical and dry and boring. And something like ban all shark fishing fits on a bumper sticker. You can make T-shirts. It fits in a hashtag. But set science-based limits for catch based on a detailed scientific understanding of life history and population dynamics does not fit on a bumper sticker. But that's a solution that we know works and has expert support behind it. So getting people, it's great that you're excited. Can we channel this excitement slightly this way? It can be a challenge because I don't want people to stop caring, but I also want them to channel their energies in a way that is what experts identify as more useful.
Great. So here's a question from Jim about an institution we all know, but Shark Week. So Shark Week seems to have a pretty mixed history. And I know the trailer for this year's is pretty controversial. What are your thoughts on this program overall?
How much time do we have? I wrote for the 30-year anniversary 2 years ago, I wrote a retrospective of the mixed legacy for the Washington Post that you can find on my website if people want to see my long rants about it. And I also have an essay about this on Vox First Person. But in general, Shark Week is the biggest platform in the world for marine biologists. And they often don't do a great job of bothering to get the story right. And when I talk about people not understanding the technical nuances or being misinformed, a lot of them learned this wrong information from Shark Week. They could do a lot of good. They often are problematic. And I'll limit my rants on this for now.
Does anyone else want to talk about Shark Week? Or
I think it's a mixed bag of things. It's sometimes it's like it needs a roller coaster because one episode can be like 100% technically good. Like I think I saw one about the Goblin Sharks that was really good, and it interviewed the right experts, and it didn't as much care about the charisma of the scientist that was talking or sensationalizing things. It was just pure like goodness. And then the very next one was about killer sharks of somewhere. What the hell? How do you go from there? That's the thing that boggles me the most, is they have the right format dialed down, but I still feel the need to have these other purely sensationalistic things that they can, I don't know, exploit somehow. I think it's exploitation.
yeah. Okay. So here's a question from YouTube user Super Ace. They ask more of a personal question, but seeking advice. If I'm studying computer science in college, how can I still work with sharks and make a difference in the world? I'd love to get a master's in marine biology, but my parents say no.
Well, there are lots of research projects that are multidisciplinary and collaborative, and we need all kinds of expertise. If you want to make sure to be involved in actually, or if your goal is to actually be out on a boat and working with sharks, like the sort of stuff that Luiz was showing, that's trickier. But to be involved in shark research, like Luiz needs help analyzing that kind of satellite data, and that takes computer programming skills.
Yeah, I was just going to say that the bioinformatics is a huge field in a huge subsection of marine biologists these days. In many cases, we're getting more data than we can analyze, and the volume of data is so big that we have to do coding, to do programming, to get access to the data, because it's so much data that we can't like open the files and look at it and compare one shark to the other, for example, because it's 6 months of temperature data. How you do that? So the skill set from the side of the computer science side is very, very valuable. you could, for example, get the foot on the door by doing a master's in marine biology, but using your bioinformatics skills. And then after that, after you start publishing things on marine biology, you can get more involved in field work, and the data that you're going to get to work on your computer is going to come from somebody that did field work. So the next time they ask you to analyze their data, you say, yeah, I want to analyze it only if you come on the boat with you. But even if the boat thing is not your thing, I know that for a lot of people out there, I overcame the seasickness thing, but I know that for a lot of people it's a huge barrier. It's just seasickness, or the fear of claustrophobia, the fear of diving. So people were like, oh, I really wanted to be a marine biologist, but I'm a claustrophobic and I can't dive, so I'm not going to be a marine biologist. That has nothing to do with it. You can definitely be a very successful marine biologist without diving, without going out on a boat. You still have to love the ocean. That's the basic fact of it, I think. If you love the ocean, you can be a marine biologist. As far as overcoming your parents, I'm just going to add something about that because I had to do it myself. I grew up in a family that my mom always insisted that I had to be like a civil engineer or a medical doctor or a lawyer, because those are the professions that make money, right? So it's I don't know if disappointment is the right word. It's going to be a disappointment. No, it's going to be a 3-minute disappointment for them. But if you do what you love, you're going to be more successful at it than if you do what you don't love. And at the end of the day, that's what it matters. I mean, you still have to make a living, but you can definitely make a living as a marine biologist, not as lofty as a living, as a coder at Google, but maybe, you never know. So maybe you can go, Google has an oceans, what is it called? Oceans Street View kind of thing that they're hiring people for that all the time. So you never know.
Those are some great ideas. And then speaking of going into grad school, Jada, we'd love to hear kind of what you're hoping to study when you start, and also about a nonprofit that you started.
Yeah, so I'm hoping to study elasmobranch, like movement ecology, like where are these animals going? Why are they going there? What are they doing when they're there? Where are they going after they leave? Things like that. I haven't picked a specific project yet because I haven't really gotten started yet because school hasn't started yet. But I'm really excited to pick a project, and I think it's going to be a lot of fun. So I'm super excited. And for this nonprofit, I am very excited about this as well. So 3 other Black female shark scientists and I started this nonprofit. Those other 3 scientists are Jasmine Graham, Carly Jackson, and Amani Weber Schultz. It is called Miss Minorities in Shark Sciences, and it is a program to help increase diversity in shark sciences, because typically this is a field that is, you see predominantly a bunch of white men, and that's wonderful, but we would love to see more representation within the field. So we started this because we really just want to be able to break down some of the social and financial barriers that people of color typically experience when breaking into a field like this. So we are doing 1, potentially 2 workshops every year for a weekend where we pay for their travel with donations. If you'd like to donate, I will talk about that in a second. We pay for them to fly out to Miami, and we work with the field school, and we have them out living on a boat for 2 days, and we'll go snorkeling and shark tagging and get people of color, particularly women of color, some experience with shark sciences so that they can get the experience they need to be able to say, hey, this is a space that's for me too. So yeah, we're just working really hard, make sure we're breaking down any barriers and really showing people that this is a space for everybody and we belong here as well. So you can follow us on social media at miss_elasmo, and you can find our website, www.misselasmo.org. There's a donate button in there. If you'd like to donate, any amount would be amazing. If not, your support is enough. We also have a Patreon. I don't remember what it is. It's probably Miss Elasmo. We tried to stay really consistent. But yeah, so that's a project that we're really excited about. We're hoping, we just started it. We just launched it like a few weeks ago. So we're hoping that in the next few years it's going to grow. We're going to really start to see some more representation in shark sciences, because as a child, I never really saw anybody that looked like me on Shark Week or on like Animal Planet in general. So we want to make sure that other kids have that representation and that we're able to help more people of color and women of color get into this field. So I'm very excited about it. And if you'd like to donate, please do so.
That's wonderful, Jada. Yeah, I just dropped the website in the comments. So please visit, please follow, please spread the word. It's really amazing that you're doing that work. I have a few more questions if you're all up for it.
Yeah.
So this is kind of a random question, and maybe you know this or not, but Lily wants to know, I read that whale sharks have teeth-shaped structures on their eyeballs. Is that true? And if yes, what is it for?
Yeah, that's research that was just published this week. They have dermal denticles, which are what sharks' outer, what they have on the outside of their body. It's why sharks, if you're ever at an aquarium touch tank and you're petting a shark and you go from nose to tail, it's really smooth. But if you go from tail to nose, it's really rough. They used to use shark skin as sandpaper because of this. So those are dermal denticles, tiny skin teeth. And those structures are found over the whale shark eye. And the paper talks about some possible mechanisms for that, but it's super weird. And that hasn't been seen before in other things.
Yeah, it's good stuff. I think I haven't read the paper yet, but just by knowing the story of it, I think they probably have it there just to keep parasites out or something out. Fish, non-sharks usually have their bodies, including their eyes, covered in mucus. And the mucus coverage it makes two things. It gives the fish two things. It makes the body more slippery, so it's more hydrodynamic. It cuts through the water better, but it also keeps a lot of parasites and things that want to attach to it out. And the dermal denticles in the shark, they have the same function. They're shaped in a way that, because they're very smooth going one way, that's the way they swim. So it makes them really hydrodynamic, but on the back, they have those crazy looking spines that at the same time serve to keep the parasites out. It's such an efficient system that it tried to, a lot of bioengineering people tried to copy it. And the two times that it was tried to copy, it was so good at it that it was deemed an unfair advantage. So if you were alive back then, I don't even know if Jada was alive back then, but in the year 2000 in Sydney, there was were you alive in 2000?
I was born in 98, so yeah.
Okay. Back in 2000, in the Sydney Olympics, they developed a full body suit for the swimmers that was based on the structure of the dermal denticle. So the microstructure of the suit had the same microstructure of the dermal denticles of the sharks, and it gave them such an advantage that that swimmers that were using it were breaking all kinds of world records. Wow. So now, when you turn into the Olympics, you only see them swimming with just the speedos on and not the full body suits anymore. And the other one that they tried to do the same thing for was for sailing boats in the America's Cup. They developed a cover for the whole of the sailboats that made them not only go faster, but also not have to clean the hull as often, because the barnacles didn't attach to it because of the shape of the dermal denticles. And that was also deemed as an unfair advantage for the boats and removed from the competition after people tried it.
Wow. It just says how,
yeah,
I don't know, how
sharks for the win.
Sharks for the win, exactly. Okay, so I think you had some, I think everyone mentioned stuff about shark tagging and radio tagging, and Michelle had a question, I think in relation to something specifically you said, Luiz, but what makes a marine reserve effective And how else can tagging be used to help protect sharks?
I'll probably start with the first, and then I will leave the other tagging issues for David or Jada if they want to answer that. I think what makes a marine reserve, many things make a marine reserve effective. The first one is, I think, monitoring and enforcing. So if you make a reserve and you don't enforce it, it doesn't work. That's the most basic fact of all. But the other one, which is really important, is how well the reserve is designed. So if you say that the reserve is supposed to save reefs, for example, and there's no reefs that are inside the reserve, it's not saving reefs. So it's the same as sharks. If you want to make a marine reserve to protect sharks, and it's too small compared to the movement of the sharks. So say the sharks, they move, I don't know, 10 miles per day, and you make that reserve 1 mile wide, the reserve is going to be too small for the sharks because they're constantly going to be swimming out of it, and then they'll be fished outside of the reserve. Likewise, if the shark has a home range or a average movement rate that they don't come out of those 10 miles, and you make the reserve 200 miles and you say it's to protect the sharks, it's just as bad because you're making it too big.
And then does anybody want to talk about tagging and other ways that this is effective to help?
I'll talk a little bit. Jada's about to be starting work with movement ecology, so you've probably started reading a lot of cool new stuff about this. But in general, the cool things that you can do with tagging are not just where does the animal go, though that's important. But there's starting to be a lot of extra cool instruments that you can add to tags. And Yanni, who Luiz showed in one of his pictures, is a real leader on this. And multi-instrument tags. That they not only record where you go, but they can have a camera that's hooked up to an accelerometer, which means there's a camera sitting on the tag, and whenever the shark accelerates, it records 30 seconds of video so you can watch the sharks eat. There have been tags that are partially inserted in the shark's stomach, so you can tell when they're digesting food because the pH changes. There's all sorts of really neat stuff that you can measure. There's been some work that's been proposed that it's really expensive to measure hurricane and weather conditions in the middle of the ocean, but animals go there. So, and we're putting tags on them already. So maybe we can put some meteorology equipment on the whale, and it'll broadcast back. So there's a lot of cool stuff being done with new technologies for tagging. But Jada's going to be working on this more than I ever did. I'm excited to see what comes of it.
Yeah, I was just going to kind of talk about kind of what you talked about, how tags are becoming way more advanced. They're not just like, where's the animal going? You can, like you said, put on a camera. You can look at what temperatures. I think some tags might be able to see the body temperature of the animal, but I'm not 100% sure about that. Okay. As well as the water temperature. So then you can kind of compare if some sharks exhibit some sort of endothermia, you can kind of see like how much their body temperature changes compared to the water temperature, which is really interesting. So there's a lot of new opportunities because of all these different instruments that people are adding to tags. And I will most likely be using some of those tags. And again, not exactly sure what species I'll be working with yet, but that's a really exciting thing. And I'm super excited to get started with that. Because field work is awesome, so
yeah,
super fun.
Something that's really interesting about the ocean that quite a few people don't know is that it's so precisely stratified in water, in different water layers, that if you know the depth and the temperature, which are the types of data that these tags collect, you can approximate quite well. I mean, depending on which ocean you are, you can approximate quite well where the shark was swimming just without knowing the precise location. So if it's like a water, it's 10 degrees Celsius and it's 800 meters depth, you know more or less where in that ocean that water flows. And then you can kind of tell if the shark was close to Hawaii or if it was close to the Marshall Islands and so on. It's really cool stuff.
Is working on tags also an option for our computer science friend, like developing new
technology? Oh yeah, technology. The smaller the better. I mean, when I started working, those tags were like massive, and now they're tiny. So better batteries, better circuits, more information, longer lasting batteries, more memory, you name it.
Another option.
Another option.
Okay, a couple more. And these are just kind of personal questions, but from Jason, for each of you, what's your most memorable experience with a shark in the wild?
I have not had an experience with a shark in the
Not
wild,
yet.
believe it or not. I think I stepped on an animal in the ocean in California when I was 16 and I lost my mind. I thought I was going to die and I don't know why. I was like, just in that moment, I was like, I freaked out. And this is again before I was as interested in sharks as I am now, because I kind of used to be afraid of sharks until I heard all those fun statistics and realized that they're really not terrifying and they're really cool and we should not interact with them, but like think about them more and understand them better and things like that. But I worked at an aquarium as an intern for a while, so I got to feed sharks and make sure that they were healthy and watch them interact with each other and see their different personalities. And it is very, very possible and very apparent when animals have different personalities, including sharks, which people think that they're all just the same. They're not. They have very different personalities, like dogs, like people, and it's the coolest thing to witness. So that's my coolest experience with sharks. It wasn't in the wild, but it was really awesome.
Luiz, David?
Go for it, David. I'll be last.
The thing that I really enjoy that I've gotten to do a lot is introduce other people to their first shark in the wild. That my PhD lab was very big on community outreach. And on every single research trip we did, we would bring a high school science class or a local club or something like that out with us, bringing thousands of people a year out on the water with us, where they would learn about local ocean science and conservation issues and get to help us work with sharks. And even for me, if it was the 400th nurse shark I've seen that year, for someone on board, it's the first time they've ever seen a shark. And you can really feed off that energy. And the difference in energy and mood between when you have high school students meet you at the boat at 6:30 in the morning versus right after we release our first shark is really infectious. So,
Nice.
Yeah.
That's cool. I'm gonna tell you an underwater experience of a shark that I had, which is, by the way, the best shark. It's not the sandbar shark. It's the treasure shark. It's the best shark. I was diving in the Philippines. It's one of those, right? The one that got away. I was diving in the Philippines at about 400 feet. So if you saw any of my other talks, you know that I do these crazy, deep, highly technical dives. I was diving in the Philippines at about 400 feet. And it was a dive that we really needed transect data and we needed some specimens. So I didn't take a camera. And nobody else on the dive took a camera. And there was 3 of us, myself, Bart, and Hudson. We didn't take a camera. We went to 400 feet. We got all the data we needed for that particular dive in the Philippines. And we went down this wall, and then we turned around and came back. And when we started going up, we looked at the ledge of the reef, so we could see the ledge, and we can kind of see the light peeking through, so that deep blue water looking up. And then we saw the silhouette of these 2 massive treasure sharks coming by. Like the most magical thing I've ever seen. These huge tails. It was like incredible. And that image got burned into my memory, and I did not have a camera.
Just gonna have to keep telling that story over and over again so you can remember it.
Yeah.
Okay, one last question from Diane. What actions would you like to see people as individuals take to help protect sharks in the future? It's a big one.
I'll start. Okay, I'll start. Sustainable seafood is really important. You got to make sure that you know where your seafood is coming from. One of the big problems with sharks is not just the finning, but also bycatch. There's a lot of types of fisheries that catch sharks incidentally, and then they toss them back in the water half dead, or just they take their fins, or you name it. But bycatch is a big problem. And if your seafood is caught sustainably, it usually means that the bycatch is minimized. I mean, the obvious one is not supporting anything that has to do with shark finning, but shark finning, again, bringing back what David said, it's complicated. I mean, if you have a shark that's back on the shore and it's going to be used for something, it doesn't make sense to throw the fins away. So you might as well just use the fins too, but it's very bad to go out and just catch use the fins. It's really destructive way of doing it, because it can be done for a long period of time out at sea by a small boat, and it can have a huge negative impact in the population. They don't even need refrigeration. So if you think of a boat going out for fishing, they have those big freezers, and they put the fish they catch into the freezer, and when the freezer's full, they have to come back, right? So, but if you have a tiny little boat, it could be, I don't know, 30 or 40 feet long, and all you want is fins, you go out and you catch thousands and thousands of fins, because they're small, and each one of those fins was attached to a shark, which is now dead. So they can have an impact of killing thousands and thousands of sharks just for their fins. So it's mind blowing. So I think from me, the big one is kind of trying to know where your seafood is coming from and making sure it's sustainable.
Thanks.
I would say definitely sustainable seafood. There's an app called Seafood Watch app. I believe it's paired with the Monterey Bay Aquarium. I don't eat seafood, but I have it downloaded anyway, just in case my friends are like, let's go get sushi. I'm like, let's make sure we're going to a good place first. But I like to think of everything as so intimately connected. So just being kind to the earth in general is going to then also positively impact sharks. So use less plastic, try to take public transportation or take a bike, like, all the general things that everyone tells you to do, plus maybe more advanced sustainable things that are available. Just being earth conscious in general is going to help positively impact the ocean, which will then impact sharks positively. So just being mindful of how your practices are impacting the earth and the animals that we share it with, and trying your best to be good about things and be sustainable.
Yeah, those are all great. And in addition to those, I just want to say many of you are watching this through the Cal Academy's Facebook page, which means you use social media and you listen to experts on social media. Be careful who you listen to. Be careful who you share information from. There are a variety of experts who you can follow on social media, and they will let you know when there's a real thing that needs your help with, or that we need your help with. There are also, as I mentioned in my talk, a lot of people who are not experts who go viral on social media spreading misinformation. So be careful who you listen to, be careful what you share. Lately, some of my friends have been saying what may be my least favorite phrase of the year, which is, I'm not sure if this is true, but if you're not sure if it's true, it's probably not true. And if you're not sure if it's true, don't share it. This is true of political stuff. This is true of science stuff.
Absolutely. Oh, speaking of social media, Jada, I don't think you shared your handle yet on Twitter.
I was just going to ask if you do that.
Yes, please. These are some experts you can.
Yeah. My Twitter handle is @sophistication. So however you would spell sophistication, and just put fish in the middle instead. I think it's kind of fun. I can't say sophisticated or sophistication like normally anymore because I'm so used to saying sophistication. My Instagram is baby_Elcock, my last name, because I'm the youngest of the Elcock family. And my TikTok is just my name, no spaces, no underscores, @Jada Elcock. So there you go.
Thank you. Thank you all again so much for being here. I'll drop everyone's Twitter handles in the comments right after we end. There was another question, which I thought it'd be fun to share with you, from Corolla, and she asks, how does it feel to be so cool?
Feels wonderful.
Feels cool.
Never get tired of it, really.
Corolla said, you're such an inspiration. I'm a marine biologist in process, and she hopes to work at the Academy of Sciences one day. So thank you for watching. And thank you everybody else for watching. Please follow our awesome panelists to keep up with their work and to fill your social media with more sharks, actual facts about sharks. And if you want to hear more about the ocean, Breakfast Club will be back next week on Tuesday with the Academy curator, Dr. Pim Bongartz, for a beautiful virtual field trip to the Southern Caribbean. So please join us then, same time, 10 a.m. Pacific. And Jada and David And Luiz, please come back and join us again soon. I think we'll be doing breakfast clubs for a while. And have a wonderful weekend, everybody.
Thank you.
Thanks for having